Okay, welcome to APNIC eLearning web class. And this session we are going to talk about the MPLS Layer 3 VPN. And for this session, first I would like to introduce myself. My name is Jessica. I'm a training officer in APNIC. And during this session, if you have any questions, please feel free to type in the chat. I will try to answer the questions as soon as possible. And after this session, I would show you the survey link, and you can also download the handouts from the FTP server. And for these slides, for some configuration examples, I have some Cisco configuration example and also some Huawei configuration examples for the Layer 3 VPN. So the agenda for this session, first we will talk about the MPLS VPN. There are different types of the VPN in MPLS technology, and in this session we are going to focus on the Layer 3 VPN. And in Layer 3 VPN, we will talk first about VRF, the virtual routing and forwarding, then on RD and RT, these two terminologies in Layer 3 VPN. These two are very important to help you understand the Layer 3 VPN, the working principle. So we will focus on the working principle process on Layer 3 VPN, so how they control the routing and also the label switching between the devices P and P routers. And the last part we will talk about the configuration. The configuration, maybe some of you are already familiar with the configuration parts, but the configuration commands are not that directly related to the serial parts. So I hope we can combine these two at the end of this session, so you know what has happened on the routers. And during this session, I hope the Adobe connector will not be disconnected, because I saw some disconnection before I started this session. Okay, so let's start this session. For MPLS VPN, when we talk about the VPN, the virtual private network, this is for the connection for different branches of one company. They want the branches in different locations. For example, one company, there is one branch in Brisbane and the other branch in Sydney. And for them, maybe they have some services need to exchange between each other. And it's impossible for that company to set up their own private connection. So they want to have the virtual private network. So they will use the infrastructure of the ISP, the service providers, so to form the virtual private network. And the VPN, there are many technologies to provide VPN. MPLS is one technology, and because of its advantages about the flexibility and address planning easy part, and so because some advantages, and MPLS VPN has been used very widely in service provider. And for the models, so in this part we will focusing on MPLS VPN. MPLS VPN, there are two types. One is based on the level, the layers, based on the TCP/IP layers. And one type is the MPLS Layer 2 VPN. The other type is MPLS Layer 3 VPN. So we know the Layer 2 is the data link layer. And so the communications between different branches are on the data link layer. And so they will form for different branches, if they are connected via the Layer 2 VPN, MPLS Layer 2 VPN, they feel like they just connected on the Layer 2 devices or connections. Maybe connected on a switch, like the VPLS, and maybe like a point-to-point connection and VPWS. And for Layer 3, the up layer of the data link layer is a network layer, IP. So for the Layer 3 VPN, we will talk about the IP addresses. So not only the Layer 2 as the MPLS Layer 2 VPN. So Layer 3 VPN, the routing paths will be exchanged between these two branches or multiple branches. And in some documents, we call the MPLS Layer 3 VPN as the BGP MPLS IP VPN. And BGP, this protocol has been used for the control plane. to allocating labels and exchange the routing information. So BGP will be mentioned in the following parts. And we know BGP, this protocol is used very widely in internet to connect different AS. And this protocol is also easy to be extended to support other functions in different address family and to allocate labels, for the control plane of the label switching. So that's why MPLS, the BGP, this protocol has been used for the control plane in MPLS. And in layer 2 VPN, different vendors, they have different focus. Maybe some vendors, they focusing on the LDP control plane on the layer 2 VPN, and some vendors, they focusing on the BGP for the signaling in the control plane on layer 2 VPN. So layer 2 VPN, there are different focuses for different vendors. But for layer 3 VPN, it's much simple and straightforward, and is just this technology, BGP, MPLS, IP VPN. So here we are going to talk about this one. And if you have any questions, you can type in the chat. For the BGP layer 3 VPN, these are the advantages: scalability, and so if you have two branches, they are talking to each other, and if you have another branch, you want to add this one, and easy to be implemented just on the PE devices, add this VPN and form the BGP neighbor relationships between the PE devices. And security, this security cannot be compared with IPsec security part. And this security is for the public network. They just think these packets are the normal public packets and just based on label to forward switch the packets. And MPLS has not encrypted the packets. It's just add the header, add the MPLS shim header inside. And easy to create. For layer 3 VPN, most configurations are on the PE device. Later we will see that one. And the flexible addressing. So for the different branches, for the enterprise, they can use their own private IP addresses, even for different companies, and they are in different VPN, so it doesn't matter whether they are using the same IP address or not, because they are totally separated. And integrated QoS support. The quality of service can be supported in the MPLS in label. So in that label, the 4 bytes. The 4 bytes, there are 3 bits for the QoS quality of service can be provided, and the mitigation is from the migration. Migration is from the from ATM to MPLS. I think this is maybe not compatible currently because we don't have this requirement. But when they design this MPLS layer 3 VPN network, and it's easy to migrate from ATM to MPLS layer 3 VPN, and then move on. About this technology, when we talk about this technology, we will mainly focus on this type of the topology. So in this topology, you need to know the positions of the devices and the names of the devices, the roles. And so you see in the middle part, these are the devices who has already enabled MPLS, like ISP, one service provider. We have the MPLS enabled here, all the devices, service providers devices. And the blue color cloud, these are representing one branch, maybe one enterprise network. They are connected to the service providers network and using the MPLS service for their communication. And the other one is the green cloud is another enterprise, another company. So we call this is company A. So they have VPN A. And for this company, there are also 2 branches. The green cloud, they will communicate with each other and then via this MPLS network. And so for this MPLS network, there are 3 roles. The routers, there are 3 roles we will mention. First is the PE router, provider edge router. So provider edge router are the border routers in the service providers network. They are connecting to the customer network, the enterprise customer. So PE routers. And then PE routers, which are also inside the MPLS network, inside the service providers network. P, we call them P routers. And they are not directly connected to the customer network. And then the customer edge. So these customer edge routers are the routers in the enterprise, in the customer's network, and the border router who is connecting to the provider's network. So these are the three roles. And especially for the service provider, when you are building the MPLS network, and you need to think about what are the capabilities should be supported on PE devices, and what are the capabilities should be supported on the P devices. So for the PE devices, all the MPLS VPN configurations will be on the PE devices. So they need to support the VPN. So how many VPN instances can be supported on the PE device? When you are purchasing for the PE devices, you need to think about that one. How many VPN instances you need to create, maybe VIF or VPN instance, and you need to create on the PE devices. Then you need to ask the vendor and then which type of devices. And in the middle, the P devices, they are mainly focusing on forward the traffic. They just based on label to forward the information. So it's mainly we need to focus on the forwarding capability. So these are different focus on the different roles when you think about the MPLS Layer 3 VPN network. These are the three roles. And as we mentioned, the most configurations are on PE devices, but the whole communication from CE to the other CE, this is what we want to reach. So in the following theory path, what target we want to reach? For the green clouds, they can communicate with each other, and they feel like they are directly connected to each other via the routing domain. And then, so for VPN A and VPN A, they will talk to each other, and they didn't feel they have passed one public network, so virtual private network. VPN, they can communicate with each other through this public network. And VPN B, they can also communicate with each other, and then they didn't feel the difference. And because this is a layer 3 VPN, so the routing information, layer 3, the IP, the routing information will be exchanged between these two branches. So these are the target. We want to make sure the branches, they can talk to each other through this MPLS domain. So in the enterprise network, we assume they are just running the normal IP part. Now we start the moving. And how can we realize from the left side, for example, left side for the control plane? And when these two different companies, they are connecting to the PE devices, and how can he distinguish these two? And he will create the VRF. So we call this is the virtual routing forwarding instance. And so here maybe in the Cisco terminology, they call this is the VRF instance. And but in Huawei, when I was working in Huawei, and normally call this is the VPN instance. So in MPLS, different vendors, the definition, the name are very different. But for layer 3 VPN, the principle is very similar. So the same principle we are working. Maybe it's of a detailed part, and they have different how to deal with the label or some attributes, the community attributes. Later we will see, but in this part they are very similar. So here for the VIF, and some call this VIF instance, or some call the VPN instance. And here we just want to, on the PE device, you can create the VIF instance, one for the VPN A, for the company A, one for company B. And so then you will bind the interface. You see, VIF associated with one or more customer interfaces. So for this interface connected to this interface, the connection to the VPN A, we will bind it into the VIF instance. So you have the VPN A instance and the VPN B instance, and this interface is to VPN A instance. and this one is to VPN B instance. So VRF A, VRF B. And after you have bind the interface into this VRF, and then all the information exchanged with the interface, with this interface, will be under this VRF, not in the public part, not in the public routing table parts. So what does this mean? Later in the routing table, on PE router, you will see, maybe I draw some square like this. You will see 1, 2, 3 on PE device. And what does this mean? This is the VRF A routing table. VRF A routing table. And then the public routing table. So this is the information when you are show IP route or display IP routing table. You will see the public routing table, the other interfaces. And for the other table is for the VRF B routing table. So you see these are the virtualized routers for different instance. We call this instance. And then 1, 2, 3. And when you are checking the information, you need to show this information or display the information separately. They will not be showing in the same table, only if you import between each other. So these are in the separate tables. And then we will see from this VPN what routing information I have learned, I will put in this routing table. And the other information I learned from the VPN B, and then I will put in the VRF B routing table. And public routing table for what? Public routing table is for the PE connecting to P routers and to other PE routers. And so the normal communication, and then we are entered in the public routing table. So this is the VRF, the communication. Then we move on. And this one should be created on the PE routers. Not only this one, the opposite side also need to create this information. And then control plane. We need the protocols to send the routing information to the other side. You see, because we want the two sides, they will communicate with each other, the two branches. And so we need to send the routing information for layer 3, different network segments. And then they will send the routing information. Which protocol will help us? BGP, the control plane. BGP will help us to send the routing information from one PE to the other PE. And before we move to BGP, I would like to answer some questions, because normally people are asking about this question. What kind of protocols can be run between CE and PE? Any type of the routing protocols. Static routes, RIP, OSPF, ISIS, BGP. You can run all these protocols between CE and PE. So it's up to you how you are running the routing protocols between them. And this is just like if you are running BGP, different AS. If you're running OSPF, and then it will form the neighbor relationship with the interface, which is under this segment. So here, these are the protocols. I may write it here. You can use the static routes and RIP. Okay, per RIP version 2. OSPF, IS, BGP. So for here, for this part, you can run these protocols. It's up to you. And normally we would see might be static routes or BGP. These are more common, but also some people are running OSPF or ISIS. But you need to specify on PE router. You need to specify in this VRF instance. So this OSPF, what I'm saying is the OSPF for the public routing table and the OSPF for the PE to CE, they are different instance, different process. So this you need to separate. That's why we have two routing tables here. and then move on from PE to the other PE when we send the routing information control plane. As we said, we are using our popular protocol BGP. So only BGP from PE to PE to send the VPN routing information. BGP will be used, and we call this is multi-protocol BGP because it's supporting a different address family, and this is in the VPN v4 for the PE to PE VPN v4 address family. And so here for the when we are using the layer 3 VPN, there are some terminologies will be used. One is RD and one is RT, and also VPN label will be allocated by MPBGP. So BGP here will allocate labels and is only for the VPN label. So label we can see because we are talking about MPLS. MPLS we are using label for forwarding. Okay, so for RD and RT, route distinguisher and route target, these two parameters are very important for the control plane, and we will explain how to use them. And also the VPN label, I want you to remember here is the first label we are using in MPLS layer 3 VPN allocated by MPBGP, and we will see how it will allocate labels. So BGP will distribute the VPN routes. What learned from CE, maybe use BGP allocate, send to PE, CE send to PE, and then how PE will send to the other side, MPBGP. It will do a lot of functions, not only one. So let's have a look. What is RD? RD is route distinguisher. I think you can see that from your devices. RD different because when you design your MPLS layer 3 VPN network, you need to design what is the RD, what is the format, and what is the which format we prefer. So RD, this one is the 8-byte field and prefixed to the IPv4 addresses. What does this mean? That means we will add the RD in front of the IPv4 addresses. So the distinguisher, what does this mean? Maybe you will think, why do we need a distinguisher? Here I will go back to our topology. So if in the VPN A and VPN B, both of them, these are some companies, maybe they are running the same. I need the pen. Maybe they are using the same private IP address, 10.1.0.0.0/24. VPN A, so I am using this block. And VPN B, I am using 10.1.0.0/24. You can't control because people are using private IPv4 addresses in their network. So if both of them, they are using this address block, and they will send it to the PE. One is 10.1.0.0.0, and the other one is also 10.1.0.0. So how can you distinguish these two? For the PE device, maybe you can see that, oh, they put in the separate routing table. Yes, they are in a separate routing table. But when this router sends via BGP to the other side, in BGP, how can we distinguish them? So we will add some information to distinguish the routes received from different VPN, different VRF. Then you see what we are doing, RD. We will add the RD in front of the IPv4 address. So whatever IPv4 address is sent from CE device to me, maybe 10.1.1.1, this address, when BGP advertise this prefix outside, and then it will add the RD. RD, who configure RD? You configure RD, you define RD. So RD totally 8 bytes, and then there are different formats. Maybe the AS number with some specified number. So some people, they will use the AS number, and for this for my AS, and what is AS number, and with some other numbers, maybe based on location or some other indicators. And or maybe you can use the IP address, and some are using the loopback address of the PE device, and using the PE device and then to define the RD. And Then maybe because the AS number before was for the 2-byte AS number, and then later nowadays we are normally using 4-byte AS number, so we will take the 4 bytes for the AS number in this part. So there are different types of the RD, the formats, and you can pick one when you design your network. But you also need to check whether your devices support the 4-byte AS number, this RD format. So these are the RD formats, and then you will pick one for your RD. And this will decided by you. And this RD, when BGP will send the routes, they will add the RD in front of the IPv4 prefixes. So this is, and after we change to this format, you see, this is not the IPv4 prefixes anymore. We call this is VPN v4 address. So here is VPN v4 address. And then we can distinguish. So every VPN VRF instance, the RD are different. And this RD will only be used locally, or only be used to distinguish different VRF locally on one PE device, this PE device. But it will be sent to the other side. And but RD should be different on this local device. Maybe you have VRF A, B, C, D, different VRFs on one device, and the RD should be different between them. And on the other device, maybe the same company, normally we will configure the same RD for the same company because they are for the same VPN, and we will configure same RD. But even you configure different RD, it doesn't matter because the matching is based on the RT information. So, and the normal practice in the ISP, they will configure one RD for the one VPN instance. For example, I have some VPN, and maybe this is the voice. Not only customer, because we are also using the layer 3 VPN for different services. So voice, maybe you design the RD. Voice RD, we will use maybe use our AS number 4654001. Oh, yeah. Oh, too much. No, not this number. So maybe RD is the 65505 is the 2. Okay, sorry, I need to add the column number. So it's 65501 colon 10 for voice. And maybe for video you create RD for the 65501 colon 11 is for video. So you can design RD for the whole network. Every PE devices, they are using the same RD for the same VPN services. And so this is a common practice. And what I want to say here is the RD, in fact, is only working locally to distinguish the different VRF. But this information will be carried to the other device. Okay, RD, and we know there is a new address we call is VPN v4 address. This is important. And now you will see here is the route advertisement. On the PE device, he has received the prefixes from the CE devices. And different VRF, we have configured the RD information. One is 100 to 1, the other one is 200 to 1 on the two device for the two different VPN instance. And when PE, they generate the VPN v4 prefix, the format is like this: 100 to 1 and 2.10.1.1.0. So the RD plus the IPv4 address. So this is the VPN v4 prefix. And this is about RD. Okay, distinguish the VRF. And then there is another information is RT. This one is the position, where we are going to use this one is a bit different. It is a BGP extended community attribute. It's a BGP attribute. What are the other BGP attributes? Next hop, origin, local preference, MED. These are the BGP attributes. So RT, it is a BGP extended community attribute. So this is a community attribute. And you can see on Cisco devices, by default, the community attributes will not be sent. So you need to enable to send the community attributes when you are using Layer 3 VPN, because RT is the community attributes. So you need to enable to send the attributes. But on Huawei devices, you don't need to enable this one. Even by default, they don't send the attributes file. But once you are using Layer 3 VPN, by default, it will carry the RT information. So there are some differences, minor differences on the vendors for the configuration of the Layer 3 VPN. So let's talk about RT. What is this one? This is a community attribute, and it will be carried with the prefix. The format is the same as the RD. So there are also you see 100 to 1, type 1 or type 2. So the types, the formats are very similar to RD. So sometimes people are confused. Are they the same information? Because sometimes maybe for one company, when they design the Layer 3 VPN, they design RD and RT are maybe similar numbers. So people are a bit confused, but the functions are very different. And RT, you see RT, export RT and import RT. So for one VRF instance, you will have only one RD. You have only one RD information here, RD. But for RT, there are two types of RT. And for each of these, you can configure multiple RT. You can have multiple export RT and multiple import RT. Okay, so how the RT is working, we will have a look. You see here, for one VRF, the RD is for example, VRFB, RD is 200 to 1, is this number. And RT, you can use any other formats. You don't need to match the 200 to 1 just because I just pick the similar number. And sometimes for one ISP, they just pick the similar number for engineers, easy to remember. So this is for the network. And then here, in this case, we are going to explaining how to use the RT. Okay, so for the PE1 and PE2, for the VRFA, we have configured the two types of RT. One is import RT, one is the export RT. Import RT, we configure 100 to 1, and export RT, we configure 100 to 1 for VRFA. And for VRFB, we have these two. And on the PE2 VRFA, we have the import RT with 3 numbers and export RT 2 numbers, and the VRFB, these are the import export. And let's see how our RT is working. When MPBGP from PE1, because they have formed the MPBGP neighbor relationship, when he is sending the VPN v4 route to the other side, he will also carry RT information. You see, this is blue color, so we think it is from VRFB. And which RT is the import or export? So in this case, when PE1 send the routing information to remote side, he will attach the export RT. Okay, export RT will be added in the update message. So BGP will send an update message to the other side. Inside this update message, in the attributes, we will carry the export RT. You see, export means when I send out, I will add the export RT. And then maybe you ask, what is the function for import? Then let's go to the PE2 to have a look. So when this routing information has been received on PE2, this PE2 will check, where should I put this route? For the VPN, put into VPN A or put into VPN B or put into VPN C, D, E, different VRF. And how can he decide? he will use the here, because in this route you have the export RT here. He will use these two numbers to match with the import RT with all the VIFs. And so because there are two numbers, maybe you will ask, should I match two numbers or only one number is enough? For the RT, only one number is enough. That means, okay, here, VIF-A, we first check VIF-A, 100 to 1, 400 to 1, 500 to 1. None of these can be matched to 200 to 1 and 300 to 1. So, okay, this route cannot go to the VIF-A. And how about VIF-B? And you see, my VIF-B, the import RT, we only compare with the import. Okay, I also circle here. So they will compare. Sorry, I draw a lot on the topology. And so you see, we will 200 to 1, 300 to 1. One number has been matched. One number, the 200 to 1 has been matched here. So the RT inside this route has been matched with the import RT. And then we will put this route into VIF-B. So this is where we are going to put the route in VIF-B. So if the other VIF can match these two, it will be in the other VIF, routing table. So this is how they put the route on the remote side. They put this VPN route into the VIF routing table, based on the RT. And normally in your network, maybe RT is not used very complicated, but RT has provided the function for you to form the very flexible topology. Just based on RT, you can realize different functions and how to put the route into the right VIF for different communications. Because we know for different branches, maybe someone you want them to communicate with each other, but some you don't want them to communicate with each other. And then we can use RT to do some control. And then we have a look at the RT. So this is just like a side and to show you how to use RT to build a different topology. VPN topology is about VPN logical topologies. So you can see for different branches, and if for the PE device, on the PE device, so for the PE devices, if we configure the import and export RT are exactly the same between each other. So you see my import matched to the other's export, and the other's import matched to my import matched to my export. So that means they can exchange the routing information on the PE devices if they configure this RT information. So we can use RT to realize the full mesh. So they will exchange the VPN routing information between each other. So for the basic requirements, we want all the branches can access to each other, and then we just configure import, export, RT. They are the same thing. Maybe you can see these cases in your network. And also some other topologies can be realized. For example, which is also a common case, is the hub-spoke. Hub-spoke, this topology, what is the function? You see the hub side and spoke size. So for this case, is like hub site is like headquarter, and in some company they don't want the spoke sites to talk to each other directly. They want to control all the traffic between all of these. So what will happen? The spoke sites, if he wants to talk to the other side, they all need to go to the hub site. So this is for the traffic. Traffic all need to go to the hub site. That means for the routing information, they have learned the spoke site can only exchange the route with the hub site. And between them, they cannot exchange the routing information. So here, this is the using RT to configure, to realize this topology. So you see the hub site, his import is 100 to 11. And whose export can be matched? All the spoke sites, they can match to this import. And his import, will be matched to his export. And this is how we are doing the communications between them. And the hub spoke, and there are also, you can configure different spoke RT and then could realize similar function on the hub spoke. So the RT, I just want to explain, RT can be used to control this route, can be whether will be accepted from on the other PE device for the other VPN, so we can control the topology. So using RT to control the VPN topologies. So these are the very important two terminologies in layer 3 VPN, RD and RT. These two are also used in the layer 2 VPN, which is called if the signaling is BGP, they are also using the RD and RT, these terminologies. So similar functions. So please, I hope you are clear with the functions of RD and RT, because these two will be configured by you. And you need to configure this information. Some vendors, they can have the automatic RD or RT information can be automatically assigned. But normally in the network, we will design a value for the RD and RT. So now we have talked about the RD and RT functions, and they will help to send the routing information. You see, there are not too many rows, only PE, and we are using MPBGP to send the routing information. And move on. Later we will go through the whole control plane again, and then you will be more familiar how it is working when we combine all these. And we talk about RD is added in front of the route. For VPN v4 route, and RT to control whether the route will be accepted on the remote side, RT, the export and the import RT, how they are matching. And because we are talking about the MPLS network label, so we need label to forward the message. Label here, when MPBGP they send the routing information, at the same time he will put a label. He will allocate labels. So for the PE1 here, and this is the prefix. You see, we first VPN v4 prefix RD plus IPv4 address. RT is the export RT will be added in the update. At the same time in the message, he will put the local label is 100. So I will allocate the local label 100 for this prefix. This prefix is learned from the CEO, from the blue color here. So local label is the label I allocated will be used by my upstream. He will forward the traffic by using the label 100. So send to this one, send to the neighbor, and the neighbor will add the label 100 into his label forwarding table. So, oh, if I go to this destination, the outgoing label is 100. So this is for the VPN label. And at the same time, you see, we only talk about neighbors between PE1 and PE2, the neighbors. At the same time, PE1 will put the next hop to himself. And for this IBGP neighbor relationship, and we are using the loopback addresses for them to access to reach each other. So we will have he will put in the next hop, because next hop is also the mandatory attribute should be added. So it's the PE1, next hop is PE1. So he will tell him to go to this destination, out label is 100, next hop is PE1, loopback address. So this is the label, VPN label has been allocated. And after we have talked about the label and the next hop is the PE1, and then we will have a look of the whole control plane. So from the CE device, I have 10110, and then I will send this prefix to PE1, maybe via the BGP, maybe via OSPF, so different protocols between CE and PE. And from PE1 to PE2, we need to form the MPI-BGP neighbor relationship in this case. And then when PE1 sends the update to PE2, there are several operations. First one, the prefix should be a VPNv4 prefix route. RD will be added in front of 10110. And then put the next hop to be himself. So whatever protocols between here, OSPF, BGP, or whatever protocols, when PE1 sends the update, he will put the next hop to be himself, and PE1 is the next hop. And he will also add the RT route target inside the update. The export RT will be added here, and the label for the VPN, we call this is VPN label allocated by BGP, and then send to PE2. PE2 will receive this information. And so here, these are the updates. Okay, so add the export RT and change the next hop to be himself, assign the label, and then send it to the PE2. And next page, PE2, you see what he has done. He will add the label into his label forwarding table and save all. Outgoing label is 100, and based on matching the RT with his import RT. At the same time, he will see, oh, this is for this VIF, and he will send the route to CE2 via the protocol you are running between them, and he will change the next hop to be himself. When he sends it to CE2, next hop is PE2. So this is for the VPN control plane, how this route has been sent to the other side. And the next hop, you need to be clear who will say next hop is which one. So PE1 will say next hop is himself. And this label 100 is for the VPN. And then we need to think about the public path. So we are keep saying, oh, 100, this label will be used from PE1 to this destination. But how can PE2 go to PE1? Based on label forwarding. We know, okay, from the PE2 to PE1, PE2 will say, oh, 100 is going to the destination, but 100 is not going to PE1. So how can we go to PE1? And then we need to have a public path at the LSP. So we call this is the tunnel label. And this is another control plane part for MPLS Layer 3 VPN. So this control plane can be run by LDP. So I need to make this a bit clear. Okay, for the control plane. So which step we are on? So here for the VPN part, we have finished it, and we allocate the information. And then, but for how can PE2 send the information to PE1? That we need a label for forwarding from PE2 to PE1. And this part, we know just one layer of the label for forwarding. But what are the protocols we're working for this control plane? In our example, we are using LDP. So public label path, the signaling protocol. The two common cases will be LDP. It's very common because this protocol is very easy to deploy and based on the IGP, the shortest path. The other one is RSVPTE. Maybe you are using this path to set up from PE2 to PE1 for the communication. And so we need to have a public path for how to send the traffic from PE2 to PE1. And we assume these are already, the labels have been set up, the LSP has been set up. So PE2, if I want to go to PE1, and then what is the label? Out label is 25. And then come to PE2, go to PE1, 1111, incoming 25 and outgoing is 50. So it will use the incoming label mapping. And if incoming is 50 and out label, here is the PHP, penultimate hop popping, and pop out label because he is the penultimate hop. And then go to PE1. PE1 will check the, oh, incoming, there is 100. So here, this is the public part, for the tunnel label, we will allocate by LDP or RSVPTE. We can use this tool for the public label. And the other option, maybe you can use the segment routing, and segment routing can also allocate labels. So maybe currently are not used that widely. So only if you have deployed segment routing, you can just run OSPF or ISS, and then they can allocate labels. But the most common cases are the LDP or RSVPTE. So this is the control plane for the public label part. And that's why in many networks, you need to run BGP between PE to PE. And you also need to run OSPF to set up the IGP path, and then run LDP based on the IGP path to set up how can we go from PE2 to PE1. So that's why we have so different layers of the protocols are running to support the layer 3 VPN. And then move on, the data plane. Data plane we can see from the, we assume all the control planes has been done. And then we will see how the labels are used to forward the packets. Because the control plane is sent from the site 1 to site 2, as we know, from CE1 sent to PE1 and MPBGP to PE2 and sent to here. And then when forwarding plane, you see, so site 2, he said, I have a packet sent to 10111. And then sent to CE1 has CE2 learned the prefix from PE2. He knows the next hop is PE2. He will send to PE2. PE2 will see, oh, 10111. Okay, matching to the IIF, to this VIF, the routing table, and the VPN label is 100. He will add 100. But the next hop is 1111, PE1. How can I go to 1111? Based on the LDP label forwarding table, and 25 will be added outside. So 2 layers of the labels are added. So this is the big advantage of MPLS. He can add multiple layers of labels. And the 25 come to P2. You see, this is the P2 device. The P devices, they don't know anything about the VPN because all the VPN configurations on the P devices. So he will only check label 25, swap to 50, and 50 pop out because this is penultimate hop. Pop out and send to P2. PE1. PE1 will check 100. Oh, 100 is the label I allocated by MPI-BGP. So he will check the incoming label is 100 and then send a packet to CE1. He knows the outgoing interface is here. So this is the control, the data plane, how the packets has been sent from here. And normally you need to check the control plane, and for control plane whether the labels has been allocated. So for some vendors devices, if the public LSP are not ready and the BGP, they will not allocate labels. So there are some relationships between different layers. And after we have seen that case, that is one example, and then we will see some application scenarios for layer 3 VPN. So maybe for as we all normally we are using for different business and different one company in the green cloud and how they are communicating and via the MPLS backbone. So this is one common case for the layer 3 VPN for different branches to communicate with each other, and the other they are passing through the same MPLS backbone. But for the core routers inside, they just swapped labels. They didn't know what are the message inside for each VPN. And then for the IP carrier network, this is also a one common case to use the layer 3 VPN. They put the different services into different VPN, and then you see for the network management, signaling and voice and media. So you can see for the MGW there are signaling and the media, and then can be the two VPN instances connected with the PE devices, and soft switch is for the signaling and connecting to the PE device, so they will bind to be the VPN instances. So these are the cases of how well the layer 3 VPN are used. You can see from your network. And then I will show you some configuration example. Here is based on Cisco device, and we will use a very simple example to show you how to do the VPN configuration, and then you can match the information to the serial path. So this is the simple example, the PE1 to PE2, this is in the MPLS domain, and two CE devices, we want them to communicate with each other. They are in the same VPN. And inside the PE, these IP addresses and IGP already finished. Configuration has already been finished. And then we focus on MPLS part. How can we make the CE1 to talk to CE2 through the MPLS network? And for Cisco devices, if you want to run MPLS, so you need to enable the IPsec. And on PE and P devices, we need to enable MPLS function. So MPLS, the LDP router ID, and in the interface enable MPLS IP and MPLS LDP. And for PE device, you don't need to enable MPLS here. You only enable MPLS LDP, which are facing to the MPLS network. From PE to CE here, we don't need to enable MPLS. We're not running MPLS to the customer. So this is the configuration from the inside the public network. And then on PE devices, you need to create the VIF and RD. You see RD information and RT. Here, in this case, I just use the same number for the RD and RT, but for your case, you can use totally different number. It's up to your design, your planning, your network, and how they are matching to each other. I just want to make sure these two sites communicate with each other, so I will configure the same export and import on both sides, and create a VIF, and then bind the interface. Which interface? PE facing to CE. So here, the interface, which here, PE facing to CE, this interface we will bind in this interface into the VIF. So here, bind the interface into the VIF. And then we will set up the BGP, the VPN v4 neighbor relationship from the PE to CE. And here, as I said, send the community on Cisco devices, RT. If you want to send RT information, you need to enable send the community both, because RT is one community. And so this is the community attribute. So here we need to enable the VPN v4 neighbor relationship. So this is a VPN v4. We call this MP IBGP. Set on both sides. And then from PE to CE, you see this is another address family in BGP. Address family IPv4, VIF, VPN-A. From PE to CE, we enable this one in the VIF, and then PE to CE, the routing path. And on CE device is in the customer. Customer, they are not running MPLS. So just go to a normal IPv4 and then enable neighbor relationship with the PE device. So here, the PE with the CE, they will form the neighbor relationship. But for PE site, this is in the VIF. And then for the VIF, after we finish that configuration, you see we have done all the configuration. And the main part people will be confused, or normally will be confused, is the address family in BGP. So on PE, we have used multiple address families, different address families. Here, VPN v4, this is where we will allocate the VPN labels, and we will send the VPN v4 route with the RD and in front of the prefix. VPN v4 from P, this is for the IBGP. You see, this is here with the IBGP label. And VPN instance, so for the VPN VRF and address family, this is for P to CE communication. So you need to distinguish these two, especially you are running BGP both internally and for the external communication. And after the configuration, on the PE, you will see the routes from both sides. I can learn the routes, the VPN routes from the two CEs. So this is the example of the configuration. And they can, on the CE device, he will learn the prefix. So you see, he will only learn the prefix from the other CE, and he cannot see the public network. He can only see the prefixes inside. And there is another configuration example is on Huawei VRP. These are very similar and the same topology we can see. And for the Huawei device, when you enable the MPLS, so the route ID, the LSR ID, and also the enable MPLS LDP and enable MPLS LDP in the interface, in the MPLS, enable MPLS function, and also create the VPN instance, as I said, they are calling this VPN instance RD and RT. They call this VPN target. And then on the interface, they will bind the VPN instance, bind the interface, bind which interface? P facing to C, that interface will be put in the VRF. So this is binding from P to C. And enable the MPIBGP, where I mentioned, you see in the VPN v4 address family, enable that one. But as I said, for Huawei, you don't need to send to the community, but for Cisco, you need to enable send to community. I think Juniper, you also need to send to the community enable, as I remember. And so from P to C, this in the VPN instance in this address family. So BGP different address family, and from the C, from C is in the normal BGP, and then send it to the neighbor. So these are the configurations on Huawei devices, Huawei VRP, and very similar, and we can see the origin of the routes, the VRF, the VPN routes. So here, when you see the VPN routing information on PE, we are not in the normal display, the BGP. It's in the VPN v4, VPN instance, VPN A. So you need to specify the VPN instance and then see the routing information. Okay, so here is the more detailed information about label. So what are the labels, the VPN label allocated for this VRF? So these are some more detailed information you can check from the devices. And the routing table on the CE device, they have learned the prefix via eBGP. So that's all for this session. And from this session, we have mainly talked about the working principle on MPLS Layer 3 VPN BGP. And we know MPBGP has been used for the VPN communication, for the control plane, for label, and for the prefix. And also the public label, we also need some other protocols like LDP, RSVP, or maybe segment routing to allocate the public labels. And at the end, I used the two examples from, in fact, one example just based on different vendors' platform. Because for MPLS, different vendors, they really have different focuses. And you will see if you choose one vendor's device, seems you have been guided by the solutions and the capabilities of the devices. But for Layer 3 VPN, it seems very similar to each other. Any questions? So I will share the slides with you from here. It's on the APNIC FTP here. You can download the slides. And here is the survey link for you.